Let me go ahead and start a new second session today. And I don't remember how to do this. Hi, welcome back. I should always start with an introduction, darn it. We are in Engineering 11. We're looking at MATLAB. This is part 2 or session 2 of class 6. The material we're looking at today has to do with creating arrays. Can you all check that this is live? I'm not 100% convinced that this is the best format. I'm open to negotiation. It looks like only 2 of you have referenced this material. I don't know if I like the... I just like the whole live stream thing is new to me, and I'm not... I see 3 people are watching. I don't know. I think there's a delay, right? Yeah. Well, the good news is I am watching this right now, so hopefully maybe Taylor switched over right now. I try to break it into sessions so that it's, instead of like 2 hours of continuous stream, you have the first half and the second half, right? But it means that you all will have to go from the first half, shut that one down, open the second one. I don't see anybody commenting now. I see 2 people watching. So you got to close the other one down, open the new one up, and then comment. Did you find this? Yeah, okay, I see you. Did you find this useful when you were at home? Okay, so 3 people found it useful. That's nice. I guess maybe I should be positive and like 1 is better than 0. Oh, maybe if you're signed in, it logs you, and if you're not signed in... Yeah. Okay. This is the second time I teach this class. I always say that the first 20 quarters that I teach a class, I suck at it. 20 quarters, not 20 times. Like 20 quarters divided by 3 is what? About 7 years. So if I taught a class continuously for 7 years, then I would start getting good at it. There is an expectation that my students have when we're writing code that I actually run through the code. I'm going to do that today. At the end of today's lesson, lessons 3, 4, 5, 6, and 7 are going to be much more paper and pen analysis combined with segments of code. And then when we get into lessons 9, 10, and 11, my hope is that I hardly teach you any code. Can you guess why I would want to teach you hardly any code by that time? Yeah, my goal is actually to show you that I am useless.
It's like, wait, what is it using there? How?
Yeah, exactly, right? And so what I will do in those saying, like I want to mentally prepare you for that, right? We can negotiate. I genuinely believe that my students are geniuses, you included. Each of you is a genius. I believe that you all are going to change the world. I cannot wait to see what you do with these skills. I know that you have needs in your learning, and I want to meet those needs. I am not committed to this. This is only the second time I'm teaching it, so I genuinely believe that everything that I'm doing sucks until 20 times in, right? As we learn together, please give me feedback about how I can better meet your needs. I don't like what I'm doing right now, but in absence of a better plan, we're going to keep going through some code. When we get to 9, 10, and 11, I'm going to straight up say, I'm going to give you a very technical problem that involves derivations of pendulums, ordinary differential equation. I'm going to have a very, very large data set that I have you load. I'm going to have you create solutions using MATLAB arrays, and all this stuff I'm going to expect that you teach yourself. That doesn't mean that I'm not going to do work. It means that by that time, you're going to have to tell me, in my mind at least, what you need me to do to help you do that. As we get closer to that date and we continue this, I welcome your feedback and I want to be better. All right. I don't see any questions posted. Could you guess how I could make Yeah, let's do this. Let me switch over to my document camera. And then I'd like you to make this matrix using both linspace and colon notation. So I'd like you to see if you can make that matrix using linspace and colon notation. Yeah, the matrix A. I would challenge each of you not to look at my code. Because, of course, the line right above the thing that's covered by my notebook is the code. Oh, I would expect that you do it in a few lines. Yeah, yeah. And then you can either post on YouTube when you have it done, or you can raise your hand and give me the finger. You can give me these fingers or these fingers. I love students smiling. That makes me... A's for everybody that laughs at my jokes. That's not funny, Anderson. It's a little funny, isn't it? Yeah? Okay. So I'm going to see if I can recreate this for myself. I'm not even going to look at my own old code. So linspace. Say it again.
The last row.
So you know what you could do here, right? You could define each row individually and then concatenate. So one thing that we might do, let's call it row 1. And it looked like row 1 went from 1 to, what, 11, and it went up by 2s. Okay, so let's go ahead and check row 1. And then row 2 went from, I don't know, 0 to 25. And it looks like it goes up by 5s, right? Row 2 star, we could do in linspace, right? So let's see, linspace, I start at the bottom, now I'm here. And then what is that, 6? Right? So then row 3 looked like something, start at 10, go up by 10s, and go to 60. I think that this is lazy code. Could you guess why I think that's lazy code? What am I trying to do with that code? I'm trying to create a one-dimensional array. Let me identify that that's what I'm trying to do there, right? By specifically saying, like, that's an array. Now, you'll see in a bit that you can use colon notation to sub-index matrices, which is why I taught that in math. It's almost like I was setting my Math 2B students up to use MATLAB, huh? That's almost like that was planned. Wow, what weird. And then the last one didn't look like there was any pattern to it, right? So maybe the last one I just do individually. Check this out. Row 1. So let me ask you this. If I wanted to combine rows, what would I delimit them by? Yeah, so what is the column? I mean, see, what does the comma do?
Separates elements in a row.
Separates individual columns. But each of those things, what is it? Rows. What would happen if I used comma? What would you expect if I did this? Yeah, that's my favorite statement of the day.
Throw a prime on it.
We could try primes. Let's try what happens if we throw some.
Doing multiple, but that works. Yeah, that does the work. What if you did a prime?
Doesn't quite do it.
It inverts all the ones inside and then connect with that.
Actually, it creates the very, very long row vector, and then changes it to a column vector. What could I delimit with these? So if I'm trying to create separate rows, semicolon. Because that says, hey, at the end of this thing, put a... Okay, should we break some stuff? Do you see that row 2 star is the same as row 2? Let me not ask you that from the standpoint of your brain. Let me ask you that from the standpoint of calculation. If I want to check that two vectors are the same, what can I do? Subtract them and take the norm. Right? Check this out. Could you guess what this code does? Oh, that doesn't work that well. The null assignment. So let's go back to row 2 star. And then what if I would like to delete the last entry of this thing. Non-colon index. Did you see that I just taught myself syntax by making mistakes? What did I do there? What was I trying to say with this thing? This is called the null assignment. Can you guess what the null assignment does? Total annihilation. It annihilates an entire row or an entire column, right? Yeah, go ahead.
How would that be stored? Like in memory, would it just zero everything out?
I don't know how that would work. That question, I mean, if I was a coder, what I would do is I would just change the pointer, right? So if you think about the answer to your question may be proprietary, right? So what I'm guessing that MATLAB does is that when you assign a array, there's a ton of data structures that sit on top of that array. So, you know, I don't think that this is going to be like a, we'll get into this deeper, right? I don't think this is going to be just 1, 2, 3, 4, 5, 6 doubles. So it's not going to be 64 times 6 bits. It's going to be something like, I don't know, a few kilobits, right? Because it's not just the entries. There's an entire data structure that yeah, right? So, but within that data structure, there's going to be a set of contiguous 64-bit double precision integers, or in this case, double precision floating point numbers, that do store, right? And then each of those entries are going to have a pointer to the address that they're at, right? So I would imagine, I don't know this because I'm not a MATLAB coder and I can't get into the heart of that, but what I would imagine MATLAB does, so let's say that I did this. Could you guess what I'm going to do there? Take the second entry and delete it. So 0, the second entry was 5, but now it disappeared, right? If I was a coder, I would not actually manipulate data in memory. Because imagine you had 1,000 by 1,000 matrix and you delete one row of that matrix. If I actually moved physical data, it means I have to do like 998 rows and move them up.
So it just leaves it where it's at
And changes the pointer. That's what I would do. Because the pointer is the address, right? So I would have an address to row 1, I'd have an address to row 2 based on memory size. The address to row 2 I would delete, and then the row 3 address, I would just replace that with...
Yeah, and then you just need to replace one address
Yep.
for like each row versus
I wouldn't even replace one address for each row. I would just say, after row 1, go to row 3, right? So I would change one address, and I would get my entire data structure. I don't have I'm not a MATLAB coder, so I don't have an answer to that question, but I'm telling you that's how I would design it, right? So anyways, that's how we deal with that problem.
But if you know a character does short, then that
Yeah. Yeah. Okay, so let's do another one. For those of you that have taken my linear algebra class, let's go ahead and do what we call a incidence matrix for a spring mass system. And I want you to get mad at me. How would you all like to be able to use MATLAB on tests in this class? Like actually use your computers on tests? Is that a vote for yes? Yeah. Okay, so then here's a challenge for you. I don't want to create a class where people cheat. I do want to create a class where you are celebrated for learning how to use MATLAB well. If, as a class, we can converge on a good way that I can make sure, because I can't be next to each of you looking at your computer screens, right? So I don't know, you could be talking to your PhD father who is Cleve Moeller. Is anybody's dad Cleve Moeller in this class? Yeah, mine neither. But I could never tell, right? So there's a challenge for you. This is an engineering problem. I would like to allow you to use MATLAB on your tests, like actually use a live version of MATLAB on your tests to be able to check your answers, etc. How do we do that in such a way that I can guarantee that the work that you do is yours and not somebody else's? You don't have to answer that question. When's the test in this class? Like 3 weeks away, right? So we've got 2 weeks to converge on and answer that question. You can propose them, and I'll challenge you back. Cool? All right, so let's do one more. I don't think that's going to work. And then we got 0, 0, negative 1, 1. I don't think I did that right. Check this out. I would like to change the... I'd like to change... Let's see. What am I doing now? Can you guess what the last thing I'm going to do here, Nick? So I'm creating a matrix C that has, see if you can see the pattern, 1, negative 1, 0, 0, 0. 0, 1, negative 1, 0, 0. 0, 0, 1, negative 1, 0. What's the last line of code I'm about to write? C 5, comma 4 equal negative 1. Check this out. I shouldn't have done C, huh? Damn it. This is for 2 people in this classroom. So, can you imagine if I allow students to use this in my Math 2B class? So I created an incidence matrix having to do with a spring mass system. Then I created a diagonal matrix where the spring coefficients are on the diagonal. And then I created a stiffness matrix which encodes the connectivity between springs and masses, and I did that in about a second. Okay. For the rest of you, just recognize that one way to create matrices is to define them entry by entry, and another way to do that is to use the diag command. Could you guess, if you wanted to learn more about diag, where you would do that? Yep. Let me ask you this. Let's go ahead and take a look at another function. And there's some detailed questions about this. Could you guess what this code does? Ready? Okay. What if I wanted, what would I do? Any guesses what that thing does? Say it again. Ready? Okay. What if I wanted to get zeros on the diagonal of that matrix? Could you guess what a diagonal of a matrix is? Misha and Nick, you cannot answer this. I mean, you can, but it'd be too easy, right? They suffered through how many hours of my life? A lot, right? These men deserve medals. I mean, all of you deserve medals for having to put up with me for more than like 5 minutes, right? Can you imagine my wife? But she chose. Can you guess what the diagonals are?
Yeah, just all the values on the, from one corner to the other.
Okay. So let's see. I want to be able to subtract. I want to get all zeros on these diagonals. So this one, this one, this one, and this one. Let's use the word row indices and column indices. What is a diagonal entry? Yeah, the row index equal the column index. Okay, so one way to do this would be to do what? Well, we could, for I goes from 1 to 4, set n of I comma I to 0, suppress the output, and end my for loop. And you're going to see that every time I end a for loop, I actually comment that this is end of the for loop I goes from 1 to 4, especially if I have multiple indices. What is n now? Ready? We'll talk more about for loops. Is there anyone that's never seen a for loop in your life? This would be a good time to identify. Before the first time I ever saw a for loop, I had never seen a for loop. Thank you. I'll be here all week. You just keep those laughs coming. All right, let's do this in a different way. Let's create a diagonal matrix out of a vector 1, 1, 1, 1. Could you guess what this matrix is going to be? What's the vector inside the code diag? Is it a row or a column vector? It's a row vector. What are the entries of it? Do you know a function that I could make that vector so that I don't have to write entry by entry? Could you guess what the function diag does? Well, let's just push enter. What did the function diag do?
It'll index go for however many arguments you have. It'll go index.
Create a matrix.
Set it to the value.
Yep.
And then it'll just do it along with that.
Everything else is 0. Should we I spy a diagonal matrix? So let's do spy of the diagonal. Don't worry about any of this. I'm not going to trip out of it. I just want to, how many people are like, whoa, this is freaking pretty weird? Yep. I'm working on it. That's going to take me like 15 years. Some of my professional goals are to turn linear algebra into at least a 2-quarter sequence, and to turn this class into a 2-quarter sequence, and to do coding in linear algebra, and to help my students make money when they finish their undergraduate degree. Right? Oh yeah, and I'd also like to get you all free tuition for all 6 years of college. That one I can't solve on my own, right? I'm gonna need some help on that one, right? But I think that's how it should be.
I do think it's funny that the students are here to make money, and they're spending money, and teachers aren't
Yeah, I have a lot to.
making money, and they are making money.
Yeah, I have a lot to say about. Well, we can talk more about that in the end of the quarter. So what does diag do? Creates a diagonal matrix. So check this out. What if we were to take this thing, and then we go back to this thing. Let's call this, I don't know, N-O, like no. Could you guess what happens if I try to subtract O from N? How big is N right now? How big is O? In general, I would highly recommend not using the letter O for a variable. Could you guess why? Looks like 0 to my eyes. Yeah, what's MATLAB going to do? It is always good to break MATLAB. Okay, but what could I do to automatically make MATLAB compensate? Here's another question. Yeah, so the question is, can I control, if I go to the diag, can I control how big diag is? I'm not going to spend more time on this than I need to, right? But we're learning some stuff about MATLAB, right? What functions did we just play with? Zeros, ones, diag. Oh, let's do this one. See if you can guess what this code is going to produce. See if you can guess it, but don't actually write the code yet. In your mind, tell me how big is that matrix? What are the entries? I think Art's got it. I think Jessica might have it. Or at least she's got the serious face on. You got it? Can you draw that matrix in the air for me? Ready? And you got to do it like that too. Nobody's laughing. You're not laughing at that? That's pretty ridiculous. Yeah, you could have done it like this too, right? Or like this, depending. All right. Let's create what we call an identity matrix. I might ask, I don't know, Nick, what's an identity matrix? How do you spell the word I? Yeah, you would expect that MATLAB does like the letter I. Yeah, it's always fun to break MATLAB. I'm going to encourage you, as often as you can, break your software and then see what went wrong and learn from it. It's my favorite way of coding, right? So if I want an identity matrix, could you guess what this one does? Isn't it really hard to figure out where the non-zero entries are just by looking at that data? I spy with my little eyes Sorry, I broke my own rule there. SPI tells you the sparsity structure of a matrix. Where are the non-zeros of that thing? Entries. Oh, sorry. You can't see that. Sorry. Where are the non-zeros of that matrix? Yeah, you could work. I mean, at some point when I get better at teaching this class, we'll write our own SPI function. In my Math 2B class, I wanted you all to write your own upper and lower triangular solvers. Backward substitution, that was something I wanted to do. Okay, so we'll close that one down. We've already talked about, what is those things called? Transposes? Okay, is anybody in Math 2B right now? Do you have a linear system that you've looked at recently? Do you have your book with you? Do you have your book with you, Wesley? Does anybody have their Math 2B book with them? Oh, tree. Do you have a linear system that your teacher has asked you to solve in the last day? Or two? Are you solving linear systems yet?
We're looking at them.
Awesome.
They've been pretty big.
Okay, so do you want to, I mean, I don't want to depress you, but I might as well, right? So sometimes I used to feel like classes were designed to be non-helpful, right? You ever feel that? Like, I'll never use that material again in my life, right?
Yes.
Yeah, okay, so let's just go ahead and flip to, I don't know. Okay, should we do this one maybe? Okay, could someone take a picture of that sucker? Just take your phone out, take a picture of this thing right here.
12?
Yep. Okay, so let me ask you this. Let's do 12. Doesn't 12 look harder? If I asked you to solve that system by hand, anybody have a rotten tomato? What would you do to me?
I'd use MATLAB.
Oh, you took my joke, man. Okay, you got it, right? So here we go. Let's define, so take a picture of this if you want it, because I can't do both at once, right? So I need to be able to have that up while I code. Let me go back, sorry, so you can see that. It's number 12. And then we're going to do some crazy stuff. I don't know, should we find LU factorizations of 4x4 matrices in a split second?
Yes.
Yeah, let's do it. Let's do it. Okay, you got it? Okay, let's go back to this thing. So I'm going to go ahead and code up the matrix A. Can someone read me the coefficients of that matrix?
We got
1,
negative 3,
-3, 4,
and negative 4.
semicolon.
We're just doing the 3 by 3.
Yep.
Then
3,
negative 7,
-7, 7, semicolon.
lastly, negative 4, 6, and negative 1.
Okay, let's do the vector B. You all are so fast. Okay, and then why don't we left divide? Ooh, I like that problem. Rank of A. Do you know what I just learned? The matrix is close to singular or badly scaled. The results may be inaccurate. We'll talk more about this for a second. Let's go ahead and see how many linearly independent columns A has. So do you know what MATLAB is telling me right now? It's telling me that I can't take the inverse of this system, but I may be able to find a solution. Nope. You don't have to worry. This is all Math 2B stuff. You don't have to worry about this in a second. But those of you that took Math 2B, do you know what I just found out? The vector B is not a linear combination of the columns of A, meaning that linear systems problem has no solution.
Rusty couch with ones across the back.
Yeah, but I don't know. Yeah, that's nice. Let's pretend that that last entry in the matrix was 2 and not -1. And let's say that we did want to solve that problem. I now have a vector x, which is going to be this thing. And check this out. A times x, can you guess what that's going to be? B. So, I mean, I happen to choose, this is why you don't want to choose a random textbook problem, because you probably want to work it out. But the point is, I mean, we could go back to this, right? Like, you know, just take your favorite problem. Like, you could take huge problems in linear algebra. I mean, I don't even know what the biggest problem in this book is. This is why I think that it's absolutely ridiculous that we teach linear algebra in the way that I learned it. Because at this point in time, you would hope that if you learned a subject, that a monkey couldn't do that subject better than you, right? I could write code in MATLAB where a monkey could solve a linear system faster than everybody in this room. So if you took pen and paper and you tried to solve it, I could teach a monkey at a zoo to push a red button that runs code that solves the linear system that you solve by hand faster than you. So in other words, if I teach you linear algebra in such a way that all you're learning is how to solve stuff by paper, you're never going to be able to make money on that, ever. Because I can write code that does it better than you every time, right? But if instead, if we were to teach you how to think about the problem in such a way that if you wanted to code it, you could get a lot of value out of that, guess what you could then get paid to do later in life? Write code. Right? It's a little bit beyond the scope of this particular incident, but I mean, should I keep going here or shut up? Yeah, I mean, Misha and I were just working on, I don't know, should I go there? Let me finish our code. Later in this class, I'm going to have some fun examples with you. I have a lot to say about this subject. MATLAB came around in 1984. So the entire academic world has had like 36 years to think about this, and we have done a very poor job because most people that know this for a living don't think that the teaching salary is worth the pain. I agree. I'm not here for the salary, right? I have a lot to say about that. For now, what I wanted to do is show you some kind of interesting stuff here. So let's create a matrix that looks like this. Let's go 1, 2, 5. And let's go 6 to, let's just do it this way. 1 to 5, 6 to 10. What's the next bit of code I'm going to write? If I want it to be squared, square matrix, how many do I have to do? So what's the next bit of code? Okay. Now, please get me this matrix. And I'm going to ask you a question. Where does the matrix B show up within the matrix A? Do you notice that every single time I'm opening, I'm trying to train myself to close it at the same time? Okay, so let's do this. Where does the matrix B show up in the matrix A? Row 2 to row 3, column 2 to column 3. What if I wanted to grab all of column 6? And I might go to either Misha or Nick on this. I want to use the column 5, sorry. Column 5. Others, if you know it, you can also split it. But
Use a colon to include all rows and then do column 5.
all rows. So what is this going to produce?
5, 10.
What if I wanted that as a row vector? What if I wanted row 3? Ah! I mean, What if I wanted columns 3, 4, and 5 of row 2? Columns 3, 4, and 5 of row 2. What if I wanted columns 1, 3, and 5 of row 1? Meaning that we can use vectors to index matrices. Should we break MATLAB?
Yes.
What's my general attitude about breaking MATLAB?
Always do it.
Do it as often as you can, right? What did MATLAB get mad at me about just
Why
now?
are you searching in the 1.5 index?
Yeah. It said, Jeff, you can't have fractional indices of matrices, but guess what it produced for me?
That'd be really cool.
Does it do floor function or ceiling function?
Looks like a ceiling.
Do you see it? Because this vector right here, if you actually look at what the index vector that I used was, 1, 1.52, 2.53, 3.54, 4.55, but it gave me entry 1, 1, 2, 1, 2, 1, 2, 1, 3, 1, 3, 1, 4, 1, 4, 1, 5, 1, 5, right? Okay. So I think that's pretty much, I mean, obviously, I'm going to have you all practice. Oh, this one's kind of nice. I got to be careful right now. Can you guess what rand I does? Produces random integers. Can you guess what rand does? Yeah, I would call these pseudo-random numbers because they're probably marked to clock times on my computer, right? It's one of the ways they do that. I want to show you the last thing here, and then we're going to take a break, and then at the end of break, we're going to come back and discuss what you might call Lab 2 stuff. I think it was that. Let's go back to mathematics, linear algebra. What do you see? I've had students ask me, do I need a textbook? There are good textbooks. There are people that write textbooks. I'd like to write a textbook in MATLAB, but I can tell you that when I write my textbook, I for sure am not going to teach you syntax. Why would I not waste, I mean, I'll show you some syntax, right? But why would I not waste time teaching you syntax?
Because the coders have already gone through and written out every single thing you could possibly know about syntax at your fingertips.
If one of you decided that you really wanted to know this and read every single help documentation piece of literature in MATLAB, I can guarantee you, you could go to the United States Air Force and sell your services if you actually understood what you read. Like the U.S. Air Force just, for all their contracts, moved over to MATLAB Simulink. There's within the last few years, right? I have a lot to say about that. But the reason that I want to say this is, what are you noticing? Do you think you could legitimately learn this in 12 weeks?
Unless you literally did nothing else and got divorced.
Yeah, I mean, I actually learned this in 4 weeks to do problems in it, right? But like, if the point was to, yeah, exactly. But I just want to show you, right? Like we've talked about this a lot, and eventually you'll get this. One of the best ways to learn this is get a really hard problem, and then try to figure that problem out. And then when you think you have an idea, find the syntax that solves that problem, right? So I'll shut up for now. Are there questions that you have before we take a break and then come back for lab? How many of you found something at least curious today? Like, whoa. How many of you think it would be awesome if you could use MATLAB on your Math 2B exams? All right. Let's start again at 12:02. I'll have some brief updates to answer Nick's beautiful question from last week. I'll also answer other questions about Lab 2. And then the rest of the time will be working time, and we'll go from there. Great work, y'all.